Okay, so I think today Rachel is on deck to talk about what she's learned about student difficulties in upper division E&M.
Right, as the title suggests. And this is work that I've been doing with Steve and also Stephanie has been helping me, and she's laid all the groundwork. And mostly I'm going to be talking about observation I made last semester in the junior level E&M 3310 class with Thomas Shibley teaching it. So he also helped a lot and let me do all sorts of stuff to his students.
To his students?
To his students, with his students. So as the title suggests, I'll be talking a lot about the student learning difficulties I observed in the upper level E&M class. I'm going to focus first on Gauss's law, and then if there's time I might talk about some others. And I'm also going to talk about weekly pre-tests that we started last semester trying to determine if the tutorials are working in the upper level E&M, if there's learning gains. So I'll start by mentioning also that this is work in progress, so I'd be happy at any time to hear your suggestions of more things to do or your comments on the way I've looked at something. So I'm very open to suggestions from all of you, because I'm still learning how to do this PER stuff, so do let me know if you have some ideas. So I'll talk a bit about the transformed class that Stephanie and Steve and Mike have all worked on transforming it. And what they did was they transformed the lectures from traditional lectures to lectures with peer instruction. They had the clicker questions with the lovely iClicker there. The office hours were replaced with homework help sessions, which were more sort of students gathered in one place at one time and sort of are able to work with each other, as well as the instructor questions. Their weekly small group tutorials were created, and conceptual homework and exam questions. And also Stephanie spent a lot of time making a conceptual pre and post test in CUE to sort of evaluate the learning gains based on the faculty learning goals and the student difficulties in the course. And then, as I mentioned, we started these tutorial pre and post tests last semester, sort of very fine-grained conceptual tests every week, sort of to zoom in on the content in the tutorials. So that's another addition. And since I had the picture of the iClicker, I thought you might be interested to know that not only can you get iClickers now, you can get skins for your iClickers. So if you would like to customize your iClicker, that is now possible. I discovered this while looking for a picture of the iClicker online.
Oh, that is the wickedest thing I've ever seen.
Oh yeah, there's many available.
They're at the bookstore.
Are they? They're
yes.
so easy to get. So in this transformation, Stephanie showed that the CUE shows that there's learning gains in the greater learning gains in the transformed courses compared to the traditional courses. The gray ones are here at CU, and the ones that have IE in them are the transformed ones for interactive engagement. And you can see they're the highest ones, and they're all above the average. So it seems that something's working in these transformed courses. And part of what I was doing last semester was zooming in on the tutorials to see if we could show learning gains from them.
Okay, just a quick question about do you have the year on that traditional versus those IEs, just from my curiosity?
Stephanie knows that better than me. I think the traditional was
the immediate semester preceding.
We don't put it on publication, so we can't link it back to a particular semester.
Mm-hmm.
Okay, it's like last year.
2007, I think.
Oh,
Yeah.
Okay, I'm just curious because the upper level are going to start, you don't know what kind of students are going in there, if there's a time lag effect or anything.
Yeah, so it's the last semester before we switched.
So like this one's immediately
Perfect,
after.
thank you.
Okay.
But there aren't any real differences between the students
Well,
coming in.
it's a different group of students, so it's.
Yes, but in terms of their GPA.
In terms of anything Stephanie's looked at, I imagine. So I just wanted to show this briefly, though. Mostly I'm going to talk about the transformed class as an opportunity to observe student difficulties. And it turns out that because there's so many new things in the transformed class, there's a lot of places to observe student difficulties. First of all, the lecture, since it's interactive. I've sat in the lecture last semester, and the students are asking a lot of questions, and there's a clicker question, so I could listen to the student discussions during clicker questions. So in contrast, I'm sitting in a more traditional lecture this semester, and there's really no way to observe what the students are thinking. And then the help rooms, I was in the help rooms every week, and so that was listening to students solving homework problems, talking to each other about solving homework problems, and then they'd ask me or the instructor if they had questions, that they couldn't solve themselves. Of course, the tutorial I found that to be a very helpful place to observe the student difficulties, because they're really grappling with the concepts there more than targeted towards an answer as they are in the help room. So it was a good time to listen to students discussing concepts. Conceptual exam questions I'm going to talk about today, because that's a sort of written evidence of conceptual difficulties. And then there's homework questions. There's the tutorial pre and post test, which are weekly, just a lot of very fine-grained weekly questions. And of course the CUE pre and post test, which is conceptual pre and post test. And of course I could do interviews. I haven't done too many of those yet, but I could do some formal student interviews. And the stuff I'm going to talk to you about today is mostly stuff that I observed in the help rooms and tutorials, and also sort of synthesized with Stephanie's previous observations of the whole course. And then I have some more hard evidence from the conceptual exam questions, and then from the tutorial pre and post tests. So the student difficulties I'm going to talk about, mostly I'm going to talk about Gauss's law. If I get to it, I might talk about student difficulties with divergence and potential. But we'll start with Gauss's law. It turns out Gauss's law is pretty complicated. It is taught in introductory courses, and I think many instructors at the junior level expect their students to have already mastered Gauss's law in an introductory course. But part of it being complicated is that it's a good place to sort of measure expert-like behavior. So the reason it's complicated, you just go over Gauss's law a little. Gauss's law, which is the integral form, is basically you can integrate E dot dA over a closed surface, and that will tell you about the charge enclosed. And the idea is that you can use Gauss's law in certain very symmetric situations to actually calculate the electric field. But in order to do that, you have to be able to pull it out of this integral, so that you can then divide it
Rachel,
over.
could you just walk people through what E and dA are?
Oh, thank you. E is the electric field. dA is a surface, a little bit of surface on the Gaussian surface with pointing normally out from the surface. And this is the charge enclosed. And this is a constant productivity of physics. Okay, so that's what all the things are to remind you of electricity, magnetism. And
You're all now experts.
yes, there will be a clicker question. So in order to use this, you have to be able to say E's a constant on the surface I've chosen, and I know what E dot dA is, so I can pull this out of the integral and just get EA on this side. So it turns out there's really only three kinds of symmetry that you can exploit to use Gauss's law. If you have a sphere of charge, and the charge distribution only depends on R, so you have spherical symmetry, you can draw a spherical Gaussian surface like this, and you can say, okay, well I know that my electric field points outward, I know it only depends on the radius, so I know it's constant on this surface, I know E dot dA is just E dA, because they're parallel, and so I can just call this E times the area of that outer Gaussian surface. So that's the logic of Gauss's law, but it's pretty complicated. You have to be able to make a sophisticated symmetry argument in order to decide what direction E points and what variables it depends on. Then you have to realize that that allows you to pull it out of this integral. You have to make a surface that exploits the symmetry you decided on. So you can see there's like a lot of different places where a student could get tripped up here in Gauss's law, and it turns out that they do indeed get tripped up at many of these places. But what's interesting is this is something that's taught, like I said, at the introductory level, and so it's not really emphasized, at least in our 3310 class, it's not emphasized very explicitly in the junior level course. It's introduced in class, there's an example, it's in one of our tutorials, but students aren't really explicitly shown how to decide if they can use Gauss's law in a particular situation. They're mostly just given situations where it works.